This video is for lesson 12.8, surface area of prisms. When we are measuring the surface area of an object, we are measuring the space that it is around the outside of a three-dimensional figure. For example, if you were painting the outside of a box, how much area would you cover with paint? Since it is area, we are measuring this in units squared, even though the object we are measuring the area around is a three-dimensional object. The measurement we are calculating is a two-dimensional measurement. Starting with rectangular prisms and cubes, these are the two formulas that we will use. For a rectangular prism, when we calculate the length times width, that is going to give you the area of the bottom of a rectangular prism. Since we have a duplicate measurement on the top, we will double that measurement. So length times width will give us the bottom, times 2 will give us the top. Length times height is going to give you the front, doubling it will give you the back as well. And lastly, width times height will give you the side, doubling it will give you the other side. For the surface area of a cube, when you calculate the area of that front square, that's s squared. And since all 6 sides of the cube are equal in size, we can multiply that by 6. Let's try these two examples applying that formula. For the rectangular prism, we would identify the length as 20, the width as 8, and the height as 16. So plugging those in where they fit, length is 20, height is 16, width is 8, and height is 16. Don't forget to include those times 2s because that will make sure we get the entire rectangular prism, not just half of it. Multiplying each set of 3 together would give you 320 plus 640 plus 256, and finally adding them gives us 1,214 centimeters squared. For our cube, we have 6 times s squared, s being 4, and the order of operations tells us that before we multiply 6 times 4, we must do our exponents first. So that is 4 squared, which is 16, times 6 is 96 inches squared. For our triangular prisms, we have our own separate formula here, and this one can be a little bit confusing. We have B, which is the base of the triangle, times H, which is the height of the triangle. Now, you might not be able to see it very clearly from here, but there is actually a duplicate triangle in the back of the triangular prism, because if you remember, triangular prisms have 2 bases that are identical. So if the triangle on the front should match the triangle on the back. So base times height, that is actually the area of both the triangle on the front and the triangle on the back. Because when we do area of a triangle, normally it's 1/2 base times height. But that would only be for one of the triangles. We also need to double it for the one on the back. So when we double it, the 1/2 and the 2 cancel out to just base times height. So that's where that comes from. Then we have A times W. A is this measurement here, W is this measurement here, and that's going to give you the area of this rectangle that's on that left slanted side of the triangular prism. In this case, A is a different measurement than H, but sometimes they are the same depending on if it's a right triangle or not. And we'll take a look at an example like that in a minute. B times W is going to give you the bottom. So B times W, that's going to give us that bottom rectangle. And then lastly, we have C times W, which is going to give us this slanted rectangle. So let's see if we can apply that formula. We have, based on the formula, this is going to be B. This measurement here is going to be W. This measurement here is going to be C. And then we have an A and an H. These are both the same. 12 is both A and H, because in this case we have a right triangle, so the height is the third side of the triangle. So those are the same. So when we plug that in, we have B, which is 5, times H, which is 12, plus A, which is 12 times 10, that's W, plus BW, that's 5 times 10, and CW, which is 13 times 10. Multiply those together individually, add them together for a total of 360 centimeters squared. Now, if that formula seems to be a bit confusing, we have another strategy that I like to use, and that is to just simply find the area of all of the sides of the figure and then add them together. So taking it one shape at a time, finding the area one at a time, and then adding them together is a strategy that works better for a lot of people. So let's show how that would work here. For this shape, if I start with the area of the triangle, we have to remember that there's two of them, one in the front and one in the back. So when I find the area, I'm going to double it. So 1/2 times base times height is our formula for the area of a triangle. 1/2 times the base is 5, the height is 12. That area is 30, but remember we said there are two of them, so we're going to double that to 60. That'll take care of our two triangles. Now we need to focus on the rectangles that go around. Those are the faces of our prism. And it doesn't matter what order you do these in. I just like to sometimes color code them or number them so that I make sure I know which ones I did and which ones I still need to do. So this rectangle is 13 times 10, which is 130. The next one we are going to do is this 12 by 5, or excuse me, 12 by 10, that's 10, that's 120. And then lastly, the bottom one, which was be 5 times 10, which is 50, taking all of those numbers and adding them together for that same answer of 360 centimeters squared. Pause the video and give this one a try. See if you can get a total of 168 millimeters squared for the surface area. You can either use the formula that's on the formula sheet, or you can try just finding the area of all of the sides separately and adding them together. The last formula at the bottom of your formula sheet is for these polygonal prisms. This is the surface area equals pH plus 2b, which is P is the perimeter of the base. We have here a hexagonal prism. So for a hexagon, when we find the perimeter of the hexagon, we just need to add up all of the sides. So the perimeter of the base, if the base is the hexagon, we are assuming this is what we call a regular hexagon, which means all the sides are the same. So the perimeter is 15 times 6 because there's 6 equal sides. And then we're going to multiply that by h, which in this case is 20. And what that does is that actually gives us the area of all of these rectangles going around, because it's 15 times 20, 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 6 times. So that's essentially what this says. This is the area of 15 times 20, 6 times. And then lastly, we're going to add twice of the area of the base, because we need to include the area of the bottom and the top. And remember, we said with these shapes, you will always be given that capital B measurement, 295. When I plug all that in, we get a total of 2,390 centimeters squared. If I want to just ignore the formula and find the area of all of the sides and add them together, for this one, we know that the hexagons are 295 and that there's 2 of them, so that's a total of, well, I guess I have that coming up later by accident, so we'll come back to that. But then we need to multiply the area of each of the faces going around the prism, so that's 15 times 20, and then as we said, there are going to be 6 of them. So when I have 15 times 20, we get 300, but then we need to use that 6 times. So that's 1800. And then there we go. There's both hexagons together is 590. All 6 rectangles are 1800 for a total of 2390. See me for help if you have additional questions.